Hello, all of you, and welcome to part 3 of bones. What we're moving on to now is what kind of bone cells are there? I don't even know where to put my face here. So there are quite a few different types of cells, and that's what we're going to go over first. So the first one is a stem cell. An osteoprogenitor cell is what it's called. And these are the cells that are going to multiply continually, and they're going to differentiate into yet another cell that's not an adult cell yet. Okay, so it's going to sort of differentiate means change into a different type of cell, and that cell is called an osteoblast. So blast means young. It's going to turn into a young cell. So you've heard a lot about stem cells, right, in stem cell research. The great thing about these cells is that they can become anything. It's a cell that can turn into a bone cell, a cell that can turn into a skin cell. And so when a cell is undifferentiated, it kind of has a free will to become what it wants to become. So here in bone, we're going to limit it to a cell that's going to become a young bone cell. It's going to become an osteoblast. It's called an osteoprogenitor cell. And these are found in bone marrow, because that's where we make these cells, in the marrow. And this is a picture of this cell that's kind of a nothing cell yet, becoming a young bone cell, an osteoblast, and then becoming a full-sized osteocyte. Okay, so osteocytes, look, they're kind of cool. They don't look like Joe's cell, right? They have these long extensions, and that's because living in bone tissue is tough. If you're a living thing and you're surrounded by something that's hard and rigid calcium hydroxyapatite, it's going to be difficult to connect to other cells because you're not right next to each other. So you're going to have to sort of reach out to these other cells to connect. So they have these really cool extensions. That's what an osteocyte looks like. Osteobone site cell. So as I said, an osteobone blast is young, so it's a non-mature cell. And where are these going to be? Well, these are going to be lined up in the endosteum, right? They're lining inside a bone, and in the periosteum on the outside of bone. Why? Because we're remodeling all the time. We're adding new bone on. If new cells need to be made, this is where we're going to sort of stash them away until needed. They're going to be able to secrete matrix, which means secrete everything that is between the cells, all the hardened part that's not a cell, but that has these substances like calcium and phosphorus and magnesium. And they're going to mineralize the bone. They're going to make the bone hard. Okay, what else? We have an osteoblast, an osteocyte. An osteocyte is a cell, a bone cell. So this is a mature bone cell. And these are trapped. They are trapped inside. Remember that if it's not a cell, it's matrix. So anything that's not cell in this bone, in this femur, let's say, is matrix. So this is where a cell's going to live, inside this little hole, and another one's going to live inside this little hole. And they're going to communicate through those long extensions. But they live inside these caves. So those spaces or caves are called lacunae for plural and lacuna for singular. And they connect to each other through tiny little canals that we're going to allow the extension of the cell to reach one cell, reaching another one. So a little canal is a canuliculi. Anytime you see iculi here, it means little. Okay. All right. The fourth type of cell here are osteoclasts. So clast is breakdown. So these are the cells that are going to break down the matrix. It's sort of alarming at first. Why would you want to break down your bone? Well, sometimes you need to. Sometimes you're remodeling. Sometimes you're growing. You need to break down some of the old bone and deposit new bone. So that makes sense that you'd break it down. And as sometimes you need more calcium in other parts of the body, and you break down a little bit of the bone and circulate that calcium. Hard to believe, but yeah. So you secrete. How do you break it down? How do you break down bone with these osteoclasts? Well, these cells are incredible. What they will do is they will secrete hydrogen ions, right? And if I put hydrogen ions together with chlorine ions, I'm going to make hydrochloric acid. And that hydrochloric acid has a very low pH, and it's going to dissolve bone. So my little picture here has to do with these cells break down bone. Did you just hear that? That's my cat meowing. There's some Amgen videos that I posted in the video section on osteoblasts and osteoclasts. So take a look at that one, and it's incredible photography. Very nice. Okay, so let's stop it here, and then we'll come back so that I can let my cat out the door. Thanks.